Great seeing you here again. My name is Luc de Ceuster, founder of the Ceuster Academy, and welcome back to a new video of our math survival guide. In this video, I will talk about finding the perpendicular line to another line, and the equation of the original line is given in the standard form ax plus by is equal to c. And we will draw that perpendicular line to one specific point. But before we continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. So let's have a look at the perpendicular line on or relative to ax plus by is equal to c. What we want to do is to find that perpendicular line through a specific point x1 and I1. We already know from the previous videos that we have to specify a point through which the perpendicular line passes through, otherwise we have an infinite possibility of perpendicular lines which are all parallel. The first step is to find the slope of ax plus by is equal to c. With the slope, we then can find the slope of the perpendicular line, because we know that the product of the two slopes is equal to 1, which means that the two lines are perpendicular to each other. The last step is where we calculate k, or the y-intercept of the perpendicular line. Now, when we look at this first step, we find the slope of the equation ax plus by is equal to c. And we know that m1 in this case is minus a1 divided by b1, or the two coefficients of the line. I refer to a1, b1 now because I consider this the first line. We also know that x and y intercept exists, and we can find those two intercepts and draw the line in the x and y Cartesian plane. So we have the different points here. We have the x-intercept and we have the y-intercept. We can find them by first setting y equal to 0. So we find c divided by a, and then we have x equal to 0, and we find c divided by b, which is also the k, or the y-intercept k. When we look at step 2, we have to find the slope of the perpendicular line. We still have the same drawing, and we know that we have m1 equal to minus a1 b1, and then we can find m1 times m2 is equal to minus 1, which gives us m2, which is minus 1 divided by m1, and we can replace m1 by the expression minus a1 divided by b1, and we find that m2 is b1 divided by a1. And this gives us the possibility to draw the perpendicular line, and we know that it has to pass through the y-intercept k2, and the equation is y is b1 divided by a1 times x1 plus the y-intercept k2. Now we have to go to the third step where we want to find the y-intercept. We have to find the line through the point x1, y1, and we find it with the two coordinates x1 and y1 in the Cartesian plane, and we see that the perpendicular line we have selected passes through this point. Now we have to find the k2 value, or the y-intercept for this perpendicular line. Now we know that y1 is equal to b1 divided by a1 x1 plus k2, and now we can find the expression that y1 is equal to b1 divided by a1 times x1 plus k2. So we have in fact the different equations that we find, and we can replace, or we can find k2 by putting all the parameters, the known parameters y1, b1 divided by a1 and x1 to the left-hand side, and k2 to the right-hand side, or like we have it here, k2 to the left-hand side, and a1 minus b1 divided by a1 times x1 to the right-hand side. And we find the value of k2. Now we have to find the standard expression of the perpendicular line to a1x plus b1y is equal to c1. So we have the expression of the perpendicular line, which is y is equal to b1 divided by a1 times x, plus the y-intercept y1 minus b1 divided by a1 times x1. We multiply both sides we put the second part, k, the y-intercept, both parts on the same denominator, and we see that we have the same denominator everywhere. So we have the new equation when all is on the same denominator, and now we multiply with a1 and we find a1y at the left-hand side is b1x plus a1y1 minus b1x1. And we bring b1x to the left-hand side, so we find the new equation, which is b minus b1x plus a1y is equal to a1y1 minus b1x1, and this is basically equal to c. And we can now write the new equation where we have minus b1x plus a1y is equal to c, and that's the result of the calculation. Let's apply this on an exercise. We consider an equation 4x plus 3y is equal to 12. We can find the x and the y-intercept. We have the x-intercept, which is 3, 0. So we have y equal to 0. So we have 4x equal to 12, which means that x is equal to 3. Then we have the y-intercept, 0 and 4. We can find this by setting x equal to 0. So we find 3 times y is equal to 12, which means that y is equal to 4. We can now find the slope of this expression of this line, which is m1, which is minus 4 divided by 3. And we can draw this in the x and y Cartesian plane. We have the two intercepts, the x and the y-intercept, and we can draw the line through these 2 points. So we found our original line. The next thing we have to do is to find the perpendicular line. So we continue with the exercise. What we do now is we know that m1 is negative 4/3, and we can find from this the slope of the perpendicular line, because we know that the product of the two slopes, m1 and m2, is minus 1, which leads to m2 is equal to 3/4. This gives us the general line or the equation of the perpendicular line. Y perpendicular is equal to 3/4 x plus k2, and we still have to find k2. Now we have that equation at 3/4 x plus k2, and we select a point x1, y2, which is the point 3, 3. So we have the line through this point, and we can now replace x and y in the equation by 3 and 3. So we have to find, or we can rewrite that 3 is equal to 3/4 times 3 plus k2, and the only unknown in this case is k2. We bring k2 to the left-hand side, and 3/4 times 3 to the right-hand side, and the 3 also. So we find that k2 is 3 minus 3/4 times 3. And we find this is 12 minus 3 divided by 4, and we have the y-intercept, which is equal to 9/4. We find the y-intercept on the graph, and now we have in fact the complete equation. We just have to transform it into the standard equation of a line ax plus by is equal to c. We can do that here very easily, because we see that we have the same denominator everywhere, which is equal to 4. So we multiply both sides by 4. We find 4y is 3x plus 9, and we bring 3x to the left-hand side. So we find minus 3x plus 4y is 9, and that's the end of our exercise. So in this exercise, we started from the standard form of a straight line, ax plus by. We determined first the slope of the line, then we calculated the perpendicular line, and then we calculated the y-intercept when the perpendicular line passes through a specific point. That's it for this video. Don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Thank you very much, and I'm looking forward to seeing you in our next videos.